Okay, it's time to get started. So this is our last lecture of the semester. Yeah, we are there already. Next week is going to be 2 days of presentations. So I imagine there's going to be half of the teams presenting the first day, and then the other half will present on Thursday. So the last lecture is devoted to going in detail in how to build these UML models, which is an important part of your project. And we started discussing the specific models that we are going to be using for the purpose of this class. I listed 5 of them. We're going to go over those today in detail, and we are also I'm going to also show you how to build those using Visio, and also a different package that I found, a software that I found online that you can download to your machines for free, and you can use that software also to build these models. You're going to have a 30-day license trial period, but that should be enough, at least for the purpose of this class. If you access one of the computers from the labs here in the 5th floor, all of them should have Visio installed. But if you cannot work here in the university, then you can use the alternative software that is already posted on Tracks. I posted the zip file for the software, and you can use that. It is free. So the references that I'm using are coming from online sources, and they're listed here. But in general, again, what we are trying to do is using these models to try to visualize the design for the subsystems and the actual system that you are working on for your project. So we are looking at UML. It is a language that allows you to visualize, specify, construct, and document the artifacts of a software-intensive system, or later years this has been used to develop any type of system. Okay, so it gives you some tools to allow you to gather information and to put together some models related to your system. So I mentioned these things already. UML is a standardized specification language for object-oriented or object modeling that is being used lately for the development of general systems. So it's a general purpose modeling language with graphical notation using to create an abstract model of a system. UML is officially defined by the Object Management Group, and you can find more information about that online. Things in these models, in the unified modeling language, include structural things, which are mostly static parts of the model. Those are called classifiers, such as class, interface, collaboration, use case, active class, component, artifact, and node. And there are also behavioral things. Dynamic parts of UML models include interactions, state machine diagrams, state transition diagrams, which we discuss in detail here in our class, and activity diagrams, which are those that are similar to flowcharts. And most of you are familiar with flowcharts. Another thing, grouping things, organizational parts in UML. We include what is called a package, but we are not going to discuss that as part of this course. There's some of the models outside the 5 that we are going to focus on that allow you to group things in these packages. And commenting things, explanatory parts of UML, you can always put notes in these models. And there's like you have in when you are revising a document in Word, that you can put notes on it or make revisions. You can also do that in this software. So type of relationships in the UML, these are 3 different type of arrows that you can use, or connections. The first one is the dependency, which involves a relationship between 2 things in which a change to one thing the independent thing may affect the other thing. Okay, so when you have this type of arrow, that's what you're trying to represent in this model. An association is a structural relationship that describes a set of links. And a generalization is a relationship in which the specialized element, the child, and we talk about this when we're talking about the class diagram, in which you can inherit some of the information from your parent. So this arrow, the generalization arrow, allows you to create that relationship. So a relationship in which the specialized element, the child, builds on the specification of a generalized element, which is the parent. Okay, so we're going to use those three to try to represent the behavior and the actual structure of our systems. So here, this is coming from Wikipedia. They have a way to represent a diagram that represents the different models that are part of UML. And as I mentioned already, we're going to focus on 5 of them, which are the ones highlighted in red in that figure. That includes the class diagram, which is part of the structure diagram, which is in this left side of the figure. And then you have the behavioral diagrams that include the activity, the use case, the state machine diagrams, and the sequence diagrams. Any questions? Okay, so in terms of the use case diagrams, again, use case are coming from the right-hand side of this figure. That's the first one listed on their behavior diagrams. So use case diagram describe the functional behavior of the system as seen by the user. And this is relevant in the sense of trying to identify some of the functions of our system. Class diagram describe the static structure of the system. So if you want to organize the elements or the components of your subsystem of the actual system, you can use a class diagram. Sequence diagram is also a behavior type of diagram that allows you to see the interactions among objects and how the activities and the functions are going to work, in the sense of you generating an input and how the input is going to be affecting the behavior or the actual actions of your system or subsystem. Statechart diagrams, another way to represent the dynamic behavior of an individual object. And activity diagrams, these are the flowcharts also to represent the dynamic behavior of your system. So you have multiple options in the sense of describing the transitions within each one of your subsystems or systems. Okay, so in terms of use case diagrams, the idea today is to show you some examples and also show you how to build those in these two softwares. The use case diagrams is a model of system functionality. Describe the functionality of the system at the environment. It is used during the requirement elicitation, used to discover some of the requirements and to represent the external behavior of the system. It is very easy to understand. I mean, once you understand what each element of the diagram represents, you can follow easily what the diagram is trying to say. So the two main components of a use case are use cases and actors. I'm showing some of the ways an actor can be represented by these type of figures. So basically trying to represent a person. And then depending on the package that you're using, you're going to have a different picture of such component of the actor. But essentially it represents the same thing. And the use cases are going to be just those ovals. And you're going to type things that are basically actions of your system. So actors represent roles. That is a type of user of the system. And use case represent a sequence of interaction for the type of functionality of your system. The actors are basically the ones that are going to trigger the use case. So actors are external entities which communicates with the system. So a user, an external system, a physical environment. An actor has a unique name. So you have to provide a unique name for each one of the actors that are represented in the diagram. For example, passengers or a GPS satellite, depending on, again, on the type of system that you're working on. A use case, which is, again, the oval. Use case represents a class of functionality provided by the system as an event flow. So you can think about the main functions of a system performs for users, cases of using that particular system. So for example, if you're looking at a cell phone, a cellular telephone, some of the functions that that cell phone can perform is to place a phone call, receive a phone call, and you can use your agenda app, for instance. So those are functions related to that system, and you can represent those using different use cases. Each actor must be linked to a use case, while some use cases might not be linked necessarily to actors. And for instance, you can extend some of the actions. So if you use a scheduler, or for example, you can use a scheduler to set up a meeting, or to set up an event, or to share a particular appointment with someone. So there are multiple things that you can do with that agenda app. And you can extend those use cases from that initial use case. So here's the example of the phone. So you can have these three use cases: place a phone call, receive a phone call, use the scheduler. And then you have the user obviously interacting with all of them. And also you have the cellular network in this case that is also interacting with placing that phone call and sending or receiving a phone call from the user's perspective. Okay. I presented a similar example. This is a library example in which a person will go, or a student will go to the library to perform one of these actions. So borrow books, return books, do research, read books, purchase supplies, and then depending on the interaction or the use case, you also have some external actors that are participating on those use cases as well. So in this case, you have the circulation desk and also a supplier which purchases supplies that are needed for the library. So as I mentioned, you can extend some of these use cases. Extend relationships, linking an optional use case to a standard use case. For example, to register course, that could be a use case for, I don't know, when you're trying to do your registration for next semester. But you can also have a use case that is inherited from this overall use case, which could be the register for a special class, or research, or register for internship. So those require special treatment. You probably cannot go and do those registration for those directly online. You might need to ask for permission to get registered in those particular courses. So the optional use case extends the standard use case. A standard use case can execute without the extend case. So this is what I'm referring to. So you have a general use case, which is register for classes. The student can access that registration desk also. But from that register for classes, you can have some extensions that register for special class or identify prerequisite courses not completed. Those use cases are extending from that overall registered for classes use case. And finally, I have an example here for an HVAC system. The HVAC system is a system that controls the operation of a air conditioner and the heater in a house or any type of structure. And then you have the interaction of the homeowner, and the two other actors are the systems, so the heater and the AC. And the use cases represent the list of actions that can happen in terms of interaction within those actors. So if you want to represent, or if you want to build a use case model, as I mentioned, you have two options with the tools that we have available for this course. So the first option is Visio. That's the first one that I'm going to recommend, and I'm going to explain why once we start using the two of them. What's going on? Just wait a minute. I mean the projector is making this showing up in the wrong place. Okay. How many of you have used Visio before? Microsoft Visio? No? 1, 2, 3. It's a very, how many of you have taken facility planning already? Never used Visio? Were you, at some point, did you build a facility plan? What did you use for that? Just manual? By hand? Okay. Interesting. Okay, so so Visio. Here's I will just type here the name is BISIO, and it is part of the softwares provided by Microsoft. Oh, great. Okay, so let's open so the other option that while this runs. So if you go to your track site, and if you go to your systems engineering class, under the resources, I posted this ED or eDraw W Maxful zip. This is the software that I'm referring to that you can use to build this diagrams. I already installed that one in this computer. This is the icon. So that eDraw Max, first one, the second one at the top. The second one at the top, that's the software. And when you open it, it looks like it's very similar to what the menu options that you have in Word or in Microsoft Office. So it is very easy to use. But let's first look at the Visio option. So there's no major challenges here in terms of using this. I think that the most difficult part is to find the right menu to build these diagrams. So when you open Visio, you have different options. If you go to new document, you have different options in terms of what type of diagrams you want to build. This is why I was asking about facilities planning, because you have map and flow plans that you can build using Visio, and it provides you with a lot of tools to build those facility planning layouts. But for the purpose of this class, we are going to be looking at software in database. So we can click there, and that's going to show some different type of diagrams. One of the options is UML model diagram. And I'm recording this lecture in case you in case you don't remember, you will have the video. So if you double click there, this is the menu options that you're gonna have. So there you have, depending on the type of diagram that you want to build, so you have UML, activity diagram, collaboration, component, deployment, sequence, state chart, and use case. So we are working with the use case diagram. So if you click in use case, you'll see that you have all the options there. So you have the use case, the actor, the different type of connections that you can use. So if I want to build something, you just select the type of, so if you want to use an actor, you can put that into the paper, double click on that, and then put the information in there. So let's say you're building this library example, so you want to have an actor that represents the student. You can change the name to student, and then click OK. Now you have the student, and if you want to add some use cases, then you can just pull them, like you would do for Arena or for any simulation package, and then you can double click in there and change the name of the use case. To the connections, well, depending on the type of connection you want to do, if you have communication, you probably just take that and you connect that to the right use case. So that, again, there's no major difficulty here. Once you understand the diagram or the type of use case you want to build, this will allow you to do that easily. You just have to put the right items in the paper. Once you're done, you can select the whole thing and do a copy and paste it in your document with no major issues. Okay, so it will work easily with Microsoft Office. If you have your diagram done, one thing that you can do, you can upload that to your U drive in Microsoft Office 365, and then you can open it online without the need of having the software in your machine. So you can do that as well. You can open it online and use it in your document. So that's another thing that you can do. If you want to use this other option, same thing, you open the software, and then the difficulty here is to find, again, the type of diagram that you want to build. So if you go to software, then you can find the use case here. So if I click here, double click there, you will have all the items that you need to build that diagram. So again, you pull the actor here, you can double click to change the name. So here it's easy, you don't have to, you're not going to have a new window, you just type the name. And then if you want to pull the use case, you can also do that. Where's the name? And the only thing about this one is that when you copy this and you want to paste it, let's say you want to put it in Microsoft PowerPoint. Since this is a student or a limited version and you have just the 30-day license, when you paste this, you'll see that it will come up with this comments. Okay, so if you paste this, one way to fix that, you can ungroup the whole thing. Let's see. So I go here, I do copy. Yeah. So instead I was able to double click. I mean, if you end up using this and you end up having those comments there, that is okay. I mean, I'm trying to give you tools that you can use within the limitations that we have in terms of computers. So another thing that you can do is just do a print screen. So if you do a print screen and you paste it in your PowerPoint, it would show up the whole thing from your screen, but you can crop it and then you can show the diagram. Okay, so that's another way that you can use that limited version of the software. So again, my first recommendation is to use Visio, but if you don't have access to it, or you cannot access the computers from the lab during the time that you have available to work for the project, then that's another option that you can rely on. So any questions so far? So from here, the discussion is simple. I'm just going to go over the other 4 diagrams. And you can do the same thing that I just presented for the use case in terms of using the software. You just have to choose the right software, or the right diagram that you want to build. And when you click on that one, the tools are going to show up in the menu. No major complication. So class diagram, we spent some time on this one already. So we are trying to do an extraction of our system in this case. And the class is going to have different information in it, including the name of the class, the attributes, and the operations. So the attributes, as I mentioned, is just information that is attached to that component of your system. So let's say you're looking at an engine, so you can put an attribute in terms of how much power that engine will generate, or how much gas consumption if it is a gas engine. So that type of information can go within the attribute part, bless you. And then the operations basically describe the functions of that component. So if it's going to be generating energy, or it's going to be moving the whole system, or it's going to be providing water, depending again on what type of system you're building, you can represent a component or a subsystem using a class. So the idea of the class diagram again is to give you an idea of how the subsystem will look like in terms of interactions of their components. So a class is an abstraction of a concept within a computer program. Encapsulate the state, attributes, and the behaviors of that thing. And the class name is the only mandatory information. So if you just want to put the class name and forget about the rest of it, you can do that. But again, the more information you have, the better idea you will have about the concept that you're trying to build. So there's different relationship in the class diagram, like I mentioned, an association, and we detail what that means. Denote relationship between classes, represent the ability of one instance to send a message to the other instance. And there's the concept of multiplicity, which we addressed also in the previous lecture, in terms of you can have an employee, and company. So one employee, or the employee is part of the company, only one company, but within the company you can have multiple employees. So you can have a number, that number associated to the number of entities that can be represented within that class. So another type, this is the association. So a country has a capital, only one capital city. And then this is the one-to-many association. So one polygon can have multiple points, okay? But all the points will be part of only one polygon. The aggregation This is showing again that composition. So here we're looking at an exhaust system, and within the exhaust system you have multiple components, so such a muffler and tailpipe and so on. So basically this is a special association denoting consists of, and you see that with that diamond representation. So basically this is saying that this system includes all these parts. The aggregate is the parent class, the components are the children class. In UML, it is graphically represented as a clear diamond shape on the containing class. So that's the type of connection that you want to use to represent the components of a subsystem. A generalization, this is the inheritance representation, so you can have a class representing a button, and then depending on the type of button that you want to use or you want to represent, then you have multiple classes. So the children classes inherited the attributes and operations of the parent class, and the generalization simplifies the model by eliminating the redundancy. And the way you represent that is by using that arrow representation, which is a white triangle at the top. Some examples. Here's an example of a bank account in which you can have different type of accounts. So you have that inheritance coming up. This is another example in which you have a company, and within the company you have departments, you have offices, so it's showing the aggregation there. And then within the department you have people who are working on that specific department. And in terms of offices, you can have multiple type of offices. So in this case we have the headquarters coming from that class. So this is a very nice example that shows the different type of connections that we are using to represent and what they represent. And this is the class diagram for the HVAC system that I presented as a use case. So again, you have the AC, the heater, and the homeowner, and what are the things that are within each use case. So if you have the use AC interface, what are the functions that are within that interface? So turning on the AC, turning off the AC. The controller has also some functions in terms of identifying what are the thresholds that are going to be triggering each one of the systems. So if you have your temperature higher than this much, then you're going to turn on the AC. If your temperature is lower than this much, then you're going to turn on the heater, and so on. So that's the class diagram. And in terms of representing the class diagram, again, the only thing that you, in Visio, the only thing that you have to do is to go and find So from that left menu, you're going to have an option that shows up the class diagram. And if you click on that one, it's going to show up the different items that you can use to build that specific model. I don't know what's going on. The three diagrams that we still need to discuss are the sequence diagrams, the activity, and the state charts. I'm going to spend more time on the sequence diagram. The other two, you're familiar with them already. apologize for this, but I'm waiting for this to go back to normal. So in terms of what the things that are on schedule for this class, do you have any questions that I can address while I'm waiting? So we have the project presentations next week. We have the project report due on Friday. You can submit that on Friday by 5 p.m. on your Dropbox. And the final exam is scheduled by the university, so you just have to show up for that. I'm going to be posting the review slides for that exam. Hopefully, at least I'm pretty sure that one of the days, the one that we're going to have 4 presentations, we're going to have some time left so I can address the review and what is expected and to discuss the material for the final. So that's going to happen next week. And I think that's it. So it's after the project, the only thing that you are going to have is the final. For Tuesdays and Thursdays, the last day is Thursday. Yes. So if Monday's Wednesday, I think you had to meet on Monday. But Tuesday and Thursdays, our last lecture is next week. That's based on the university calendar.
Okay, so May 2nd and May 4th, we're having a lecture here?
I don't know. I mean, the last week of classes for Thursdays, Tuesdays and Thursdays is next week.
Oh, next,
No, like
sorry,
27.
Next week. Oh, why do I have classes?
Okay, so going back to this. So if you want to create a class diagram, here, in this case, you have to go to static structure, and there you're going to see the class and the different arrows that are needed to build a class diagram. Okay, so if I want to build a class diagram, I go to the static structure, I click on that, and I have the class. You double click on the class, you can change the name, you can change the attributes, which is again in this side of the menu, and you're gonna have like a spreadsheet. You can put the name of the attribute here. For the purpose of this class, that's about what you need. If you're gonna put an attribute, you don't have to fill out the whole table. And then you have different type of arrows here. So this is the composition, which is the diamond. In this case, the diamond is not white, it's a different color, but it represents the same thing. And you have the aggregation, the generalization, and so on. In terms of sequence diagrams, again, this is the only one that is left that is new. I know you're familiar with the other two. Sequence diagrams represent system behavior in terms of interactions between the system entities. So these complement the class diagram, which is representing the actual structure of your system. And it is useful to find the participating objects. It could be for a subsystem, the component level, the subsystem level. Again, this is very useful in order to identify those that are part of. Time consuming to build, but worth the investment. You'll see why. Can be used for creating system test scenarios. So if you're going to put your system in a specific, excuse me, it's not, You watching something on your cell phone? Okay. So can be used for creating system test scenarios. So when creating a sequence diagram, this is the overall structure. So you have the different objects at the top. Each object is going to have a line. The line, what it represents is the time horizon. So messages are going to be passed between the entities, the objects, and those are listed from top to bottom according to the time in which they're going to happen. So the first messages that are passed are going to be at the top part of the diagram. Latest ones are going to come towards the bottom. Okay? So, for example here, we have a passenger that is trying to purchase a ticket, probably to go for a train ride. So you go, as you can see, the passenger here is represented as a actor. You don't have to put an actor, you can just use one of these boxes. But the initial time is time 0, putting that here. And the first message or interaction with the ticket machine is going to be represented at the top. So here you're selecting the zone, and then you insert the money, and then you pick up the change, and then you pick up your ticket. This is a bar that is representing a continuous time action. So I'm doing all these things in a sequence. I'm not stopping. So I do this, then I do this, then I do this, and so on. When you move to the other line here, you see that at some point these actions are stopping. So I select the zone. After that selection is performed, I'm done with that step. And then I move to the next step, I'm done. So those bars are relevant in the sense of knowing how much time it is taking to perform these things. Okay, so the sequence diagrams are used during the requirements analysis to refine the use case description and to find additional objects that we might not consider when we were doing the initial concept representation. Are used during the system design to refine subsystem interfaces. Classes are represented by columns. Messages are represented by arrows. Actions or activations are represented by narrow rectangles, which are the ones that are here. And lifelines are represented by the dotted or dashed lines, which are these ones under those bars. So another example here, if you're using or you're trying to set up the time of your watch, this is what this is trying to represent. So you have the simple watch, the LCD display, and the time. And according to the actions that you do to set up your watch, that's what we are trying to represent here in the sequence diagram. Obviously, if you're viewing an initial abstraction of your system, once you start looking at the things that you need to perform in the system, you start understanding if you are missing an object or not. Okay, so that's the idea of these diagrams. It allows you to think, so if I'm going to perform these actions, what are the things that I need to have in the subsystem, the system, or the component? Okay, so the source of an arrow indicates the activation, which sends the message. Another example, we have a teacher that is trying to log into a computer. So here's the representation of that. And again, the HVAC system. This is the sequence diagram. If you want to represent the sequence diagram or use Visio, I think you have a menu for it. And since I'm having issues, I'm going to let that towards the end. So in terms of Statechart diagrams, these are the state transition diagrams that we did at the beginning of the semester. So it's the same idea. You have states. One additional detail that I already mentioned is you can illustrate what the system it's going to start. So you can use this black dot to show up the initial state. And then according to that, you know what's going to trigger the next states of your system. So this shows the life cycle of an object. State is a condition of an object for a particular time. An event causes the transition from one state to another. And here's the state chart for a phone line object. So you're familiar with this one. I'm not going to spend a lot of time here. Showing again the initialization or the initial state of your system. Where the system terminates, it's represented by that dot with the white circle. So that shows up where the last step of the last state of the system is after the transitions. And here's the state transition diagram for the HVAC. Finally, the behavior diagrams, activity diagrams. So these are the flow charts. An activity diagram shows the flow within the system. And this is a special case of the diagram that we just discussed. And you're familiar with the notation. So you have this rectangle with these corners to represent the actions. And then you have the diamonds representing decisions. Okay? That's the main idea. And you can also use those circles to represent the beginning and the end of your process. Okay, so in summary, we have 5 different diagrams. I would like to see those represented in your presentation, and also at least one of each of them. And also, there's a document in your project report that addresses these diagrams in particular. So you have to make sure that you have some of those in your project. So in summary, UML provides a wide variety of notations for representing many aspects of the system development. It's powerful but complex language, and is used in system modeling for model-based system design. We describe some of them, not all of them, including the behavior model, the use case structure, which is the class diagram, and the behavior models, which include the sequence, state chart, and activity diagrams. Any questions? So again, today we have some time left. So if you want to use that time to meet with your teams and work in your project, you're welcome to use that time for that. I'll be here in case you have questions. And I'm going to post this lecture video today. So if you want to access the video, it's going to be on tracks.
That way on Thursday.